Now let's talk about the future. So, the future is definitely GPUs everywhere. Well, it's GPUs everywhere we have a screen. So if we look at this group of computers here, yep, we got a screen in mobile devices, got a screen in desktops, laptops, got screens in your cars and on your watches. We'll have GPUs in all these places. But if we look here at a data center, there are no screens in data centers. We won't have any GPUs. Supercomputers, no screens, no GPUs. Cell phone base stations, huge amount of computing power, but they don't have any screens. So we're not going to see any GPUs there. So what's going on here? I said GPUs are more efficient, and we've seen supercomputers are using them these days, so why am I saying we won't use them in the future? Well, the basic answer here is that GPUs are just one example of a bigger trend, and the bigger trend is heterogeneity. So GPUs are winning because they're specialized for the task. Nothing special about GPUs, they're just specialized for a particular task. Heterogeneous processing says use different hardware for different tasks. So if you map the hardware to the task, you can be more efficient. And that's what GPUs are doing. They're getting better efficiency and performance because they're better designed architectures for certain specific tasks. So this is not a question of CPU versus GPU. It's a question of big processor cores for latency. So if I want to run 3 different things, I want each one to finish quickly, I care about latency and I want a big processor core. And that's what we show here. We had that processor core with lots of stuff around there to make that one pipeline run fast. So it's big processor cores for latency versus small processor cores for throughput. So I'm doing lots and lots of pixels in parallel or big numeric simulation. I don't care about each individual one, I care about all of them together. So what do I want? I want a whole bunch of small cores to give me good throughput. So it's not GPUs everywhere we have a screen. What it really is, it's heterogeneity everywhere. And the heterogeneity we'll see in devices with screens is CPU plus GPU, but the heterogeneity we'll see everywhere else are big CPUs and little CPUs combined together to get the same efficiency. So GPUs where we need graphics, and we'll use them for other things than graphics. But everywhere else we're going to have heterogeneity for efficiency. We don't need graphics in any of these situations here, so why would we use a graphics optimized device? We'll use a CPU that's more optimized for different types of CPU programs. So where's heterogeneity today? Well, we see it all over the place. So NVIDIA's Tegra 3, well, they got 4 fast cores and 1 slow core. It wasn't a very successful example of heterogeneity, but they put it in there. ARM sort of cornered this big little idea with this small processor core and a big processor core, and they have them designed for different power benefits. So the small processor core is slow and power efficient, and the big processor core is fast, but used a lot more power. So you can choose which one you want for the right workload. And AMD's Fusion. Got a whole bunch of CPU cores for CPU-like things and a whole bunch of GPU cores for GPU-like things. So the key to all of these things, you match the software to the hardware for efficiency and performance. And that's what heterogeneity is all about. So why are we moving towards heterogeneity? Well, there are basically 2 reasons. Power scaling has stopped, and we're power limited everywhere. So power scaling has stopped. This has some interesting implications. This doesn't mean that Moore's laws end. We're still making smaller transistors. So we can keep making smaller transistors, but they don't use less power. So if I double the number of transistors on my chip, but the power doesn't go down, that means I double the power of my chip. And that's a real problem. Power limited everywhere. We're limited by batteries and mobile devices and cool and everything else. So we can't just use more power. So if power scaling is stopped, I can't double the amount of transistors and double the power because I don't have any more ability to have more power. So what's going on? We can't build more cores to get more performance because we can't afford the transistors, and we can't burn more power to go faster because we can't afford the energy or the cooling. So what does this mean? Well, what it means is the only way to get more performance is to improve energy efficiency. And this is really the key thing in computer architecture this decade. That if we want to get better performance, we have to improve efficiency. And this is why Intel put these older Pentium cores in the Xeon Phi and not new cores, because they were more efficient. So what this says for us is heterogeneity is the key because it matches the hardware to the software. If you have hardware that's optimized for your particular software, you get better efficiency. And if you can get better efficiency, then you can get better performance. And that's the only way to get better performance because we're power limited. Better efficiency, better performance. So takeaway messages. GPUs are really great because they have nice software. We saw graphics as this perfectly parallel, no synchronization, throughput-based thing. It's easy to scale. We're reaching the end of power scaling. That means if we want to get better performance, we have to focus on efficiency. Efficiency is the key thing. And to get good efficiency, we need heterogeneity, that is matching the hardware to the software. And we saw here is GPUs are just one example. GPUs are processors that are optimized for graphics programs, and if your program looks like graphics, you get better efficiency because it's optimized for that sort of program. If your program doesn't look like graphics, you don't get better efficiency because it's not optimized for it. We also saw the tools are immature. It's really hard to justify rewriting your applications if you're only going to get a 2 to 3 times speed up. So it's going to take a long time before people get over this hump. And finally, the future is heterogeneous systems. So we'll have these big latency optimized cores and these little throughput optimized cores all over the place, but we're only going to have GPUs where we have screens. GPUs only make sense if you're doing graphics. Otherwise, you want processor cores that are more optimized for general purpose processing.